Back, my friends. Let's get ready for that quiz that I keep talking about that you wanted some review on. So, a couple things that you need to know is that if you remember, we defined some of these irrational numbers. We talked about e, we talked about phi, we talked about pi, we talked about square roots, we talked about logarithms, and some of those classic constants, those numbers that sometimes have letters and Greek letters assigned to them. We did some activities. We did some exercises on how to get those, how to, I want to say construct, but not with a compass and straight edge, but I mean like how do we mathematically construct some of these numbers. And I want to ask you to see if you can identify some of those by the construction. And I will just leave that at that. So my point is review some of those. After that, we're going to talk about distances. So we had, just any two coordinates. I believe we said, what is it? It was 2, 5, wasn't it? 2, 5 and 1, 4, negative 1, 4. Thank you. And I said, hey, what's the distance between those? So obviously the point is that you need to be able to find the distance between any two coordinates. This is something that supposedly you learned back in IM1, maybe even before that. And it basically is just a Pythagorean theorem. It's just the triangle, the ABC. So an idea here would be to make a little rough sketch of like where the coordinates are. And so I'd have like 2, 5, like 1, 2, 3, 4, 5. So I'd say, hey, here's 2, 5 approximately. Negative 1, 4, we'll say that's right here. And then you can have, make a triangle. So you have one leg of the triangle, you have another leg of the triangle. This one has length 1, this one has length 3, and then we make a hypotenuse, and we say, hey, how long is that hypotenuse? Well, Pythagorean theorem, 1 squared plus 3 squared equals hypotenuse squared, which I'll call c. So this equals c squared. And if we do this out, then we get 1 plus 9 equals c squared, which means that 10 equals c squared, which means that c equals the square root of 10. And that would be your answer on how to find the distance between 2 points. So any point on the coordinate grid is fair game. You need to be able to find the distance between them. That's what's on the quiz. All right. And then some more things. So let's look at a little bit of a different problem. Oh, I can. Yeah, okay. Well. Yeah. No. Okay. So let's look at some other problems. So one other thing we have to do is we have to rationalize the denominator, which means basically if you have a fraction of some kind and the denominator is a square root. Go ahead and shout out two numbers, like anything from 1 to 100. 12 and 73.
No, how about 75?
It's fine.
2.
It's fine.
How about 3? No, how about give me...
No. She's right. We'll do whatever you say. 12 and 73. That's fine. So let's say that the denominator is root 12 plus root 73. How do you rationalize this? How do you make it not irrational? Because I don't know if you remember, but you're actually not allowed to have an answer where the denominator is irrational, like in terms of like the square roots and stuff. So we have to re-express this. Do you remember how?
You put it to the top.
We have to multiply this by something.
Go to the top.
because I don't have one. And then all they give me is the curriculum and the activities. So, and well, I mean, then there's some exams that are floating around. You know, but this is what we have. So, what do we do? Well, and nobody knows?
Do you multiply them by I don't know.
We're going to multiply it by the conjugate. That's right. Don't be getting any ideas. So this is negative. So we're going to do root 12 minus root 73. Oh, yes. And you'll see why. Because the denominator is now the difference of squares. So if you remember, if you have like a plus b times a minus b, you're supposed to know that that equals a squared minus b squared. And so that's exactly what's going to happen here. In the denominator, we're going to get 12 minus 73. And in the numerator, we'll have root 12 minus root 73. So the numerator still has the irrationals, but the denominator is now rational, because if you simplify this, you're going to get 12 minus 73, which we all know is negative 61. So negative 61. And the numerator is still root 12 minus root 73. And so this would be the answer. So the key is really that you know how to do this, and that when you multiply by this, that you get this right here. Because that's the key to making the denominator not irrational. Yes. How do I solve that? Well, tell me your question.
So once you multiply by the what's it called, conjugate,
Mm-hmm.
you remove the square root off the bottom.
Okay.
The numerator transfers over, and then you just minus the denominator.
So, just like in this scenario up here, if you have some quantity plus another quantity and multiply it by the first quantity minus the other quantity, you get the difference of their squares. Which for square roots is very convenient, because if I square root, I undo the square root. And so I just get that number. So I get 12 minus 73 in the denominator. And that's going to be a rational number. It's going to be a whole number even. Well, I'm sorry, an integer. Negative 61, yep. So, yeah. Yeah, there's nothing you can do. Okay, like, if I could factor out something between them, but I can't. They're relatively prime. Okay.
If I could solve the square root, then I would use those numbers. If it was like
Don't worry about that. All right. Final problem. And another thing we have to do is we have to simplify some expressions. And what I mean by that is particularly ones that contain radicals. So this is plus. Here's my little example. You can go ahead and try to work this out yourself. If you're watching online, you can pause the video and then resume to hear the explanation, which I do recommend.
I never did it online. I skipped the answer.
Then If you skip to the answer without doing it, you're missing an opportunity for growth. You're missing an opportunity to learn how to do it. In fact, when you do watch YouTube videos about learning math and stuff, you should always pause and do the problem. And if you're stuck, then you watch the video again only until the point where you get unstuck. And then you pause it again until you can do that. So, let's look at this one. Root 75. Well, this all comes down to prime factorization. The way that you simplify radicals, prime factorization. Root 75. Let's look at 75 real quick. 75 is what times what? Any factors that you know? How about 5? No, even better. Well, I could do 5. 5 and 15 is 1, but how about 3? 3 and 25. And then this will be 5 and 5. So what that means is that 75 equals 3 times 5 times 5. And if I was to take the square root of this, then this would equal square root of 5 times 5 times square root of 3. Well, that's really square root of 25, or you can write 5. That's really 5 root 3. Okay, so this part right here is really 5 root 3. So if I have 2 times 5 root 3, then this becomes 10 root 3. Plus 4 times...
Wait, question.
Yeah.
The 5, right here, 5, 3,
Mm.
you wait to multiply it by the outside number until you broke it down.
You mean like this 10 here?
Yeah. So you
That-
multiply the 5 by 2.
Yeah, so the purple thing that I circled here,
Is 5.
that's 5 root 3.
Yeah.
So 2 times that would make it 10 root 3. That's why I wrote 10 root 3 in green.
Got it.
All right, so then let's look at root 48. And we're just going to do the same thing. We're going to take 48, root 48. How do you want to break it down?
6 and 8.
6 and 8, okay. And then 6 is what times what?
3 and 2, and then 4 and 2.
3 and 2, 2 and 4. And 4 is just 2 times 2. So that means that root 48 is really 3 times 2 times 2 times 2 times 2, which means that it's root 3 times root 16. And that, of course, is also known as 4 root 3. And so if that's 4 root 3, then this right here will be 16 root 3. And then root 27,
On our test, you're going to give us perfect square roots like that. That still be a number on the outside and that.
if you consider that to be perfect.
What if they're both square roots, though? Like,
What do you mean?
Like how you have 4 times square root of 16, right?
Okay.
What if they were both, like, square root of 3? And I can't pretend to do it.
Which one are you talking about?
I'm just saying, like, on the test, they're going to be like this.
Yeah.
They're gonna be easy.
I mean, I'd say these are easy. Okay, finally, root 27. So root 27, that's 3 times 9. And that's going to be root 3 times root 9. Otherwise known as root 3 times 3, or 3 root 3. Now, what does that make our answer? The answer is 23 root 3. Because 10 plus 16 is 26, and 26 minus 3 is 23. So it's kind of like 10x plus 16x minus 3x. What is that? Well, that's 23x. But it's not x, it's root 3.
What is the root for different?
Then you can't add them. It's kind of like terms. Yeah, if they weren't the same, you couldn't add them. You just have to leave them alone. And that pretty much concludes our little lesson review about the quiz. Thank you for watching. Please don't forget to tell your friends about what a wonderful video this was and how much it meant to you. And tell them to subscribe to our channel and buy non-existent merchandise. Call the school and make a donation to the tennis team. All those things. Okay.